Good day, guys. Welcome once again to Social Tutor Academy, where we embody our motto from confusion to clarity and from test to testimony. Today, we're going to be talking about limits of some important functions. So, we've done a lot on limits, limit and continuity, L'Hopital rules, and so on and so forth. Now, today, we're going to be looking at what limit of some important function. So, we are going to be looking one under what exponential, under what trigonometry, also what logarithm. So for today, we are going to be looking at the one under what trigonometry. So what are these things you have to know? Limit of x. Limit of x tends to 0 of sine x over x is always equal to 1. This is the first one. And the second important one you have to know is the what? Limit of x tends to 0 or what 1 minus cos x over x is always equal to 0. These are the two main things you have to know. Okay, let's try to move this. So let's say limit, we said limit of x tends to 0 abi, and sine x over x is equal to 1. So let's use L'Hopital rule, the one close, very close to what 0. Let's now use like 0.1. 0.1 is approximately what 0. So you should write limit of x tends to is 0.1. Sorry, limit of x tends to is 0.1 of what sine x over x. Are you getting me? That we want to try to prove that this is equal to what 1. So we use a very close number. If I approximate 0.1, it will give me what 0. So anyway, I see I write what 0.1. Sine is 0.1 over is 0.1. Now using our calculator, we have what sine 0.1 over 0.1 should give us what 0.998. If I should approximate this will give us what 1. Now let's use a more smaller number. Let's use like 0.01. Limit x tends to 0.01 of what sine x all over x. So anyway, I say I put on 0.001 sine 0.01 over what 0.01. Now put the calculator again. We have what is 0.9998. We have what is 0.9998. Can you now see that what this is what approaching to what to 1? Approximately it is what 1. Then this first equation is correct. So and for the second one, you want to prove it again. We have what limit of x tends to 0. Let's also use what is like 0.1 or so. 0.1 of what 1 minus cos x all over x. So this one give us what 1 minus cos 0.1 all over what 0.1. So using our calculator, 1 minus cos 0.1 over 0.1 will give us what is 0.05. 0.05. I see that approximately this one too will also end up getting what 0. About the next whole number is what 0. That is a more smaller value like 0.001. Using 0.001, I know that we want to like 1 minus cos is 0.001 over what is 0.001 abi 0.01. So using your calculator again, we have what 0.005 is 0.005. Can you now see the more we go downward, the closer it is to what 0. This one is also what correct. Now how can question come on this? Let's take some questions. The first question is that what limit x, find the limit of what of when length is tends to 0, 5x over 5. 5x okay sine 5x over 5, sorry, sine 5x all over 5. We have what limit x tends to 0 or what sine 5x over x, sorry, sine 5x over x. How are you going to solve this? So from here now, what you just need to do is that what you know that sine x over x is also always equal to 1. Then you have to represent this to be also being in what? This what is here must also be what is inside the what? The denominator. I get it. We have sine 5x over x. That can just say what? Times 5 over 5. Are you getting me? 5 over 5 is what? 1. So it doesn't affect the equation. Times 5 over what? 5. Then for me, I can now say what? Limit x tends to 0 of what? 5 sine 5x all over what? All over 5 times x is what? 5x. Don't for now, can you see it? 5 times sine 5x times 5 will give me what? 5 sine 5x. 5 times x will give me what? 5x. Now don't forget that I said that what? Sine x over x is equal to what? 1. Now I'm adding what? Sine 5x 5 sine 5x over 5x. Remember sine 5x over 5x means what? Limit of what? X tends to what? 0. Limit of x tends to what? 0 of 5, right? Multiply by what? Limit of x tends to 0 of what? Sine 5x over what? 5x from the rule, from the basis of what? Of what? Of limit over 5x. So this one is a ordinary constant, so it will still remain the same. 5 times. Now, limit of x tends to sine 5x over 5x. Let's say 5x is equal to like y. Are you getting me? So sine y over y is what? 1. From this formula, sine x over x is what? 1. Sine 5x over 5x is also what? 1. So 5 times 1 is equal to 4, what? 5. That's the final answer. A shortcut you have to use is just that what? What's the coefficient of x right here? 5. What's the coefficient of x right here? 1. 5 over 1 is what? 5. That's the shortcut. Are you getting me? Let's move on to the next what? The next question also. So we have, let's say we have sine 2x over 5x. Limit of x tends to 0. Sine 2x all over what? 5x. How am I going to be solving this? Sine 2x over 5x. This is very, very simple. So we know that the answer is what? 2 over 5. Coefficient of x here is what? 2. Coefficient of x here is what? 5. But you have to show your workings because it's written. Okay? Assume it is a what? Written exam. So we have what? Times what? Can I say times 2 over 2? Are you getting me? Times 2 over 2. 2 over 2 is 1. It doesn't affect this. Are you getting me? 1 times this is this. So times 2 over 2. What I'm going to do is that what? I will substitute this for this. Are you getting me? Now, if I say 5x times 2 and 2 times 5x or and 2x times 5. This one will give me what? 10x. This one will also give me what? 10x. So is it the same thing? What I'm going to do just is I will switch this. So I'm going to be having something like what? Limit x tends to 0. Sine 2x will still remain over, instead of now 5x, I'm going to put what? 2x times. This one will remain 2 over. Instead of writing 5 there, I'm going to be writing, instead of writing 2 right here, I'm going to be writing what? 5. As simple as that. And then sine 2x over 2x is what? 1. So 1 times limit of x tends to 0. So sine 2x over 2x will give me what? 1 times what? 2 over 5. So 2 over 5 times 1 is still what? 2 over 5. As simple as that. Are you getting me? Just like coefficient of this is what? Coefficient of this is what? 2 over 5. As simple as that. That's a shortcut. So now, let's move to another question. Hope you are getting it. It's very, very, very simple. Let's move to another question. Sine 7, limit of x times 7, sine 7x over sine 3x. Limit of what? X tends to 0, sine 7x over sine 3x. Wow, this is quite funny. But we're having both sine right here, sine right here. Okay? So our answer will still be what? Coefficient of x is what? 7. The coefficient of x is what? 7 over what? 3. Okay, let's see if our answer will still remain the same. Now, unlike this one that you just be having a trig up and a normal and an expression down. Now we are having trig in both the numerator and the denominator. What are you going to be doing? You are still going to be using the same sense. What are you going to do for me is that what? You multiply this by what? 7. Sorry, let me change the marker. So we multiply this by what? Limit of x tends to 0, sine 7x over what? Sine 3x as the above. Now multiply by what? 7 over 7, each parameter times 3 over 3 times x over x. This one is going to that what? 1, 1, 1. 1 times 1 times 1 times 1 times this will not affect the what equation. So what are you going to be doing right here? What you are still going to be doing is what? Substituting. Are you getting me? I'm just going to interchange the value. Now, if I want to rearrange it, I'll just say what? Limit x tends to 0. Sine 7x, I'll remain it to be what? Sine 7x. I will not change it over. Then I will now write sine 3x. I will now write this. I will now take this and take this. Now this one for everything now is now a what? One particle like this. So I will now take, instead of writing sine 3x direct under it, I'm not writing sine 3x direct under it, but I'm just going to take it what? 7 and x. So I'm going to be having what? 7x. Are you getting me? So 7x multiplied by, at the above right here, I'm going to be taking this 3. At the above right here, I'm going to be taking what? 3. 3 all over. Now, I'm not going to, you know that, instead of writing 3 under 3, I'm not going to be writing what? Sine. Okay, I'll take 3x, sorry, rather, I'll take 3x, this 3x rather. And I'm going to be writing 3x over what? Sine 3x, right? Multiply by, so now, multiply by, what remain right here in the numerator right here is what? 7 all over. What remain right here is what? 3. Do you get it? Now, limit of x times 7 or 7x over 7x. Just like, let's say your 7x is what? Y. Sine y over y will give us what? 1. Multiply by, let's say 3x over 3. Let's say 3x over sine 3x. Is it the same thing? 1 over 1. That's to give us. So this one to give us what? 1. You understand? W over what? Sine w. This one also give us what? 1 times what? 7 over 3. So 1 times 1 times 7 over 3 will give us what? 7 all over 3. If you should remember, I said the shortcut is just what? The coefficient of x here is what? 7. The coefficient of x here is what? 3. 7 over 3. 7 over 3. Do you see how simple it is? Now let's move further. We are going faster. So let's move to another complex question. We have right here, we have limit of x tends to 0 tan x over x. Limit of x tends to 0 sine x tan x over x. Limit of x tends to 0. Limit of x tends to 0 tan x over what? Over x. How am I going to be solving this? Limit of x tends to 0 tan x over x. Don't forget the first thing. Let's first put this. This thing also means what? Limit of x tends to 0 tan x multiplied by what? 1 all over x. Are you getting me? This one means what? Limit of what? X tends to 0 tan x multiplied by what? 1 all over x. I've been able to split this. Then don't forget that from your trig identity, tan x is equal to that what? Sine x over cos x. So you have what? Limit of x tends to 0. So instead of tan x, I'm going to write what? Sine x all over cos x times what? 1 all over x. Now from there, I'm going to be using the substitution method. Let's just changing the denominator. I'll put this one here, I'll put this one here. So I'm going to be having what? Sine x times 1 sine x over. Then I'm now writing cos x right here. I'm going to write ordinary x times what? 1 over what? Cos x. So I put this here and I put this here. So limit of x tends to 0 of sine over x will give us what? 1 times limit of x tends to 0 of 1 over cos x is what? 1 all over cos 0. And don't forget that cos 0 is what? If you place in your calculator, cos 0 is what? 1. So 1 over 1 is still 1. 1 times 1 is what? 1. As simple as that. So if you check the coefficient of x right here is what? 1. The coefficient of x right here is what? 1 over 1 is still what? 1. As simple as that. Hope you are following. So let's take another question. Taking another question, we have what? Tan 4x over 3x. Wow. You can pause the video and lay your hand on that. Tan 4x over 3x at limit of x tends to 0. How are you going to be solving this? How are you going to be what? Solving this? So we use the same method. So let's first say limit x tends to what? 0 of what? Tan 4x multiplied by what? 1 all over 3x. I split it again. And tan 4x is the same thing as what? Sine x over what? Cos x. So we are going to be having limit x tends to 0 sine 4x all over what? Cos 4x multiplied by what? 1 all over what? 3x. Are you getting me? Now, what's the next step right here? I'm going to be multiplying both. I want to multiply this by what?